So the prerequisite for this video is that you must have seen the part 1 of this video. I will just put the link in the description below. If you haven't seen that, please check it out. And apart from that, you must know the concepts of pointers and basics of tree. So let's begin. So in this video, we will implement the same problem but with the different approach. We will use recursion in this tree to find the maximum node who's having maximum sum of its children and node itself. So what is the basic three things in recursion? As we know, the first we have a base case in recursion, then we have induction step, and then we do some small calculation on the basis of which we generates our answer. So in this tree, the base case would be a node who's having no children. Let's say if I'm at this node, I will call recursion. If I'm at this node, I will call recursion for its child, for all its child. So it will hit the base case when it reaches the leaf node who's having no children. Then it will simply return the data present in it. So it will return the 6 itself. Then that is our base case. What is the induction step? Let's say if we at this root node, we will call recursion on this, and we will assume that this recursion will give me a correct answer from all of these subtrees present in this node. Uh, as we can see here, this subtree will return me a correct answer for the smaller problem itself. That is our induction. Okay, we can see that thing from here. This is my node, and there are, let's say we have three children, and we will these three children as three subtrees. We will take the whole tree below this children as a subtree, and for same for these two also. So when I call recursion on these subtrees, I will assume that this will return me a node who's having maximum sum of its children and itself present in this subtree. Similar for this node and same for this one. And finally, after getting these three value, I will compare it with the root itself, root sum itself, and in the end I will return my answer. So this is my small calculation part, which is the third, part of my recursion. So I think that we have enough idea of recursion. So let's take this example. So from this subtree, I think this 3 node is the maximum sum node. So 3 will be returned from here because its sum is, I think, 3 plus 5 plus 6 is 14, and this is 6 and 5 only, and from this subtree there's only a single element, a single node in it, so it will return simply 2. Now let's see in this subtree, for this fourth node, 4 node data, whose data is 4, the sum would be 4 plus 7 plus 8 plus 9 plus 10, 38. And let for 7 it's 7 only. For 8 it is 8 plus 5 plus 40, I think it's 53, and it is 9 only, and it is 10. From this subtree I will return 8th node, because 8th node has maximum sum 53 in it. We will not get into how it will return me 8. We will just assume that recursion will give me the maximum node in it. Okay, 8th node. Now after returning the 8th node, we will then compare this with root, and 2 with root and 3 with root, and we will get the maximum value, maximum node who's having maximum sum. So that's the whole thing that we will do in this code. Let's jump to the code. Okay, so in part 1 we have implemented this problem, and now we will make a function for recursion. Let's name it. Return type would be same, tree node int star. Again we will, let's name the function maxsum node 2. We will pass head root in it. Now in this main function, yeah, it's 2 already. Okay, so let's take care of the edge cases. If root equal to null, we will simply give a response null. Okay, and if now the first step is that we have to calculate the sum for the root. So let's make a node. I'm naming it max. And let's calculate the sum. Let's take a variable answer who's having max data in it. For calculating the sum for children, I will run a for loop that will be running from I is equal to 0 from max children max is a pointer. We cannot have dot here. Dot is used for objects. Max children size. Children is a vector and there's a function named size for vectors. Okay, so we simply will add max. I think we should use root here because there's a I'm worried that though it will not make any effect on the code. Okay, root children data. Okay, let me name it int template named tree node int star. Okay, I have put 3e here. Now it's fine. Okay, so now we have calculated the sum for the root. Now it's turn to call recursion for all the childrens of root. So again I'll make a same loop. Root children dot size root children dot size I plus plus and there's issue here why it is saying that max is uninitialized. Actually max, we haven't stored anything in max, so we cannot do this max data. We have to store root in it. I forgot to store root in the max, so now it's fine. Okay, so in this for loop I will be calling recursion for all the childrens and will compare the value of the sum with the root sum. So recursion, when I will call recursion, the return type is node star. Tree node star means it is a node pointer of tree. Then I should make a variable so that I can store that value. So let's name that variable temp. Tree node temp is equal to max sum to node 2, and I will put root children I. Okay. Now I have got the value of the I've got the node in this temp variable. So what should I do in order to compare this temp node with root? I need to calculate the sum of the childrens of temp. So I will make a variable temp sum, in it I will put temp data. Again I will run a for loop, int I equal to 0, I less than children dot size I plus plus. Okay, I plus plus, and again I will do the same. Okay. So I hope you guys understand that I am performing. I'm doing this. I'm calculating this sum for this temp node, and up here also I'm calculating this sum for my root node. Now I simply need to compare this answer variable and this temp sum variable. So I will do that in this for loop itself. If temp sum is greater than my answer, what should I do? I should update my answer. Answer is equal to temp sum. So next time I will be comparing with my temp sum, which is stored in answer, and I should also update my max node to temp node. Okay, I think it is fine. So similarly, we will run this loop for all the children, and eventually in the end we will get the maximum answer. Okay. So in the end we will simply return max. I think this should work. So let's, and in the main we are calling this maxsum node2 function. Let's call the build the function. Now it's built successfully. It means that it's compiled successfully. So here we are giving the input of this tree. We are giving the input of this tree. So I think the answer is 8. Final answer is 8. So let's try to give input. Now my max node is 8. So first it has printed the tree, and now in the end it has given answer as 8th node. But there's an issue in this code. Okay, let's look in this for loop. What work we are doing in this complete function? First we are calculating the sum for the root node which we have input, and then after that we are calculating the sum for its children. Before that we are calling a recursion on each children. So it means that recursion will calculate all the sum of all the nodes in the subtree, and it will give me a final node. And again after receiving that final node in temp, we are again calculating that sum here again. So we are doing the same task multiple times. So it will obviously cause us some time complexity problems. So in order to avoid that, what we can do is the problem is here that this recursion is only returning the node. It is not returning the sum for that node. So we need to return two values from the recursive call, but I think it's not possible. Or is it? Yeah, it is possible if we make a class who's having two data members of the node itself and the sum itself. So for solving this problem, we will make a class whose name, let's name that class pair. We also have inbuilt pair class uh, template which you can check on Google, but right now I'm making it so that you guys can understand it better. So in this class, I will have two data members. First would be my node. My second data member is, let's say, and some nodes. Okay, so these are my two data members. So I think this is my pair class, which is fine. Now the return type for this function will simply return to pair star. And we have to make some changes in this code. Again, the input will be same. We will only give input of root of the tree. Edge case will be the same, and int star max. Now instead of making this node class tree node, we will make simply pair star max is root, not root pair star max. First we have to allocate its memory. New pair, that's fine. Now max node, as it is a dynamic pair class, so max, will put arrows here. Max node will store max node or root, and here I am calculating the sum for the pair max. So int answer, yeah, and in the final we'll simply put max sum nodes is equal to answer. Now we have stored this answer in this pair max. Okay, and in this loop will be fine, I think. And again here we will making a pair class temp max sum to root children. Yeah, it is fine. And now we don't need to perform these steps. So what we will do, we will simply compare my temp some nodes, some nodes with answer, and if my temp sum node is greater, I will simply put answer in temp node and max as temp. I think temp sum, okay. Temp sum nodes, yeah, it's fine. And in the end we will return max. So in the main function we cannot store a pair class into a tree node variable. So we need to, as it is a pointer, we need to do it this way. Now it will work fine, I think so. Yeah, it has built successfully. Now let's give it a tree. Yeah, again now it worked fine. So as we can see that we have made a pair class, and that pair class, when we are calling recursion on that pair class, we are simply getting the pair value in the temp. It means that temp has a node which has maximum sum, plus it has also a variable named sum nodes who's storing the sum in it. So we don't need a for loop for calculating the sum of that node. Okay, so we are simply just comparing it here directly. So that's the goal here, which we have succeeded. Thank you, and if you have any queries, please comment down. I'll be happy to reply. Bye bye.